Hello, welcome to what will be a very special session with Digital Futures as part of our Insider series, where we look at the research going on at the leading doctoral research centers around the world. Today, we're going to be focusing on Tongji University in China. I should say that I'm standing in for Philip Duan, who's unable to be here today. Also, Tomas Vivanco, whom we've had to present, is ill and unable to present. But before I introduce the speakers, let me just make a few other announcements. First of all, tomorrow we have the final session in our Digital Futures by FIUD DES Doctoral Consortium, where we're looking at books, AI, and the city. An extraordinary series, which is all uploaded to the Digital Futures library. That has been very successful. And the final session tomorrow will have Imda As and Sylvia Carter talking about their two books about AI in the city. Also, the deadline for the Digital Futures Conference, Digital Intelligence, has been extended until the 29th of November. So that's Tuesday. You will hear what have been accepted on 26th of December. It's a Christmas present or otherwise. This I would recommend has been a really worthwhile conference. It is completely free. There is no registration cost. It's the only conference I know in the world. And it's published with Springer, so a very high research rating as well. The information you can find at the bottom there on the Digital Futures International website. So Shanghai, let me just say a few words about Tongji in general, about Shanghai overall, first of all. And that's that as somebody coming from abroad, as soon as you land in Shanghai, you're very much aware that you are in a very sophisticated city. Shanghai, you land at Pudong Airport, and then you can be whisked into Shanghai itself on the maglev train, which is the fastest running commercial electric train in the world, going at a standard speed of 431 kilometers an hour. That's 268 miles an hour. And that really gives you the sense of the kind of the technology and the advanced way, the very sophisticated way in which Shanghai operates. And then you arrive at this city that really could only be described as something that kind of that sort of echoes in some senses the vision of Blade Runner of a kind of a very advanced metropolis, especially with these three very significant buildings on the Pudong, the center of Shanghai along the Vivanco River. There is an astonishing display where you gaze across at the new China in the Pudong, and these three very significant buildings, including the third tallest building in the world, the Shanghai Tower, that was designed by Gensler. And then we have the International Center, that is the World Financial Center, which is designed by KPF, the Oriental Pearl Tower we can see there, and the Jinmao Tower by SOM, which at one stage was one of the tallest in the world itself. So here you can see the International Center by KPF, referred to as a kind of the bottle opener, as it were, and you can see the Oriental Pearl Tower here on the front and the foreground. So this is an extraordinary kind of amphitheater, shall we say, of extraordinary buildings. And from the left-hand side, from the Bund, from Buxi, from the 1920s and 30s buildings on that back, you can gaze across at this extraordinary spectacle of one of the most sophisticated and advanced cities in the world. And indeed, people do. The promenade along the Bund is absolutely packed. You can see the 20s and 30s buildings there, many of them designed actually by British architects, at a time when Shanghai was the international gateway into China. And since then, it's now taken up that role again. Shanghai is famously certainly in the old area behind the Bund, was divided up into certain concessions, but internationally for different countries, of which the French concession remains perhaps the most dominant. But there we have the old world on the left-hand side and the new world on the right-hand side, this extraordinary amphitheater spectacle of the new China, the great sign of progress in many ways, and an indication of the future of China. And just to kind of give you some sense, I mean, something like the Empire State Building is completely dwarfed by the Shanghai Tower. It's nowhere near as high. We're talking about the most impressive skyline, far more impressive in many ways than even the Manhattan skyline. And in there, you can see an extraordinary mix of going on of these pleasure craft, that take you around, and these working barges, working ships that are plying the river the whole time. An extraordinary bustling city, an extraordinary international city. And it's in this city that Tongji University, sorry, I'll just show you at night. This is how you know you're in China, because the way in which the lights all come on together at the same time. And indeed, at night, they all go off at the same time as well. But it is China, and it is an international city. It is the third largest city in the world, 26 million people, an astonishing city. And it's here that Tongji University is situated. And today we're going to have some presentations both by the College of Architecture and Urban Planning, CAUP, in Tongji University, and also across the road, the new Department of Design and Innovation. Both of these ranked among the top departments in their field in the world. And you can see here this is the QS ranking from this year, where you can see this is from 11 to 20. The University of Cambridge, one of the most established universities in the world, where I studied myself at 11. Tongji knocking on the door, as it were, in 13th place. And what's interesting, I think, about this particular section is the number of universities from Asia that are making their way into the top rankings. University of Hong Kong, PolyU, and then the University of Tokyo. So there are only actually two American universities, UCLA and Columbia University, that make this rank. So Tongji has been working its way up the rankings and is now number 13 in the world for architecture. Perhaps most famously in terms of Digital Futures, it's where we held a number of in-person workshops over the years. And perhaps out of those workshops, the most famous of all were the installations that Duan put up for bridges, testing out prototypes of bridges. This, the second ever bridge to be 3D printed in the world, behind one from Yak. So it's been an astonishing place that is leading the world in many ways, and certainly ranking right up there in terms of the quality of its education. And here we have Patrik and Philip Yuan testing out one of these bridges. And they have been literally every year, there've been bridges being made, although we haven't been able to be there in person because of COVID for some time. Patrik will be here as well later on, and hopefully I'll be able to introduce him. Patrik, great. Okay.
I've been listening to you online.
Well, Patrik, maybe you'd like to, before I introduce the speakers, maybe you'd like to say a few words about the about Tongji and the kind of the doctoral research that you've been part of at Tongji. I don't want to put you on the spot, but would you like to say? Well, I can carry on.
Yeah, of course. Well, I mean, I subscribe to what you said about Shanghai in general. I love the city and I love the Tongji campus, and particularly the School of Architecture. It's been an incredible hub for many years now, with these amazing conferences and workshops. Digital Futures conference are amazing events connected up with these fantastic workshops and great displays of the results of these workshops. Very, very fantastic place. I'm very proud to be part of it. And now I'm teaching in the PhD studio for quite a while, and I have one very interesting PhD underway. We will hear about later. Unfortunately, it's only a 10-minute kind of quick summary. But yeah, it's an exciting place, really sophisticated, great people coming there. You know, the threshold to join is very high, particularly for the Chinese component, but in generally, the international students are very high caliber. And we have these group sessions, which is really important, and seminars and lectures and debates, but also regular update presentations where all the PhD students in the group can see their peers being critiqued and being critiqued in turn. So I think that makes for a very good experience compared to many other PhD scenarios where you're kind of isolated. And I think I've tried to do something similar in Vienna with a group of students. That has come full circle. I finished that, and now I'm fully, with respect to PhD research, Tongji is my place.
Great. Okay, Patrik, thank you. So let me just simply say a few words about I'll break this up into two sections. We'll do the 5 CAUP candidates, the PhD candidates first, and then our two colleagues from across the road, Design Innovation, Duan and Krid after that. Just to say something briefly, I wonder if we could actually maybe start with Snow, but just to say that Snow is herself a graduate of the ADRL. She's now working for Zaha Hadid Architects, and like many people, she is kind of combining the doctoral research with her other activities. Virginia Melnyk is someone you will have come across for Digital Futures. She's been part of the core team for Digital Futures. Currently, she's teaching at Virginia Tech. She's a graduate of UPenn and is, I think, coming towards the end of her PhD at Tongji. Andrea Macruz, so Virginia has been working with Philip Yuan, I should say. Andrea Macruz has been working with me. Andrea is a graduate of the ESAC Biodigital program in Barcelona, where a number of significant figures have graduated over the years. She's currently teaching at Didi, a school in UAE, and she's undertaking her PhD at Tongji. Tomas Vivanco, unfortunately, can't be here today. Tomas is doing some really wonderful work. He's ill. Alongside everything else, Tomas is a professor in the Pontifical University of Chile. He is a graduate of IAC in Barcelona, and he's also, I should say, he was also the captain of the Chilean rugby team. It's a shame that Tomas can't be here today. Marcus Farr is also teaching UAE at the American University of Sharjah. He is a former Fulbright scholar and took his master's from Rice University. So I will introduce Duan and Krid afterwards. Maybe we can then I'll stop sharing and we could start the presentations. Snow, would you like to share your screen? Welcome. Snow is in Beijing right now.
Yeah. Thank you, Neil, for the introduction. Yeah, let me share my screen. I think you can see my screen now.
Yeah.
Yeah. And also thank everyone in the team who make this session happen. So hello, everyone. I'm Xuexin Duan. I'm a PhD student at the School of Architecture from Tongji University. So today I am presenting part of my PhD research under supervision of Patrik and Philip Yuan. The research is about optimizing for orientation and navigation in the complex space. So after a quick intro, I will briefly introduce the methodology, the prototype, and the one experiment. So the research context is in response to this increasing demand for collaboration and knowledge exchange within the net society. Both virtual and the physical spaces are becoming more and more complex. So therefore, the orientation and navigation within this increasing complex scenes becomes a problem that architectural design must address. So the goal of this research is to upgrade the architectural design competency in this respect by setting up a workflow for evaluating and optimizing the legibility of the complex scene. The theoretical basis of the research is spatial cognition, and then the research content is focused on the orientation and navigation. The scenario will focus on the atrium space in the architectural complex. And the hypothesis is in the space, the relationship between the diversity of destinations and the ease of search will be a nonlinear trade-off graph. Increasing diversity will reduce the ease of search. So in order to achieve the goal, the idea is to develop a systematic workflow for simulations that can appraise and rank the design proposals in terms of complexity and then legibility. This is an overall methodology concept framework. By doing a serious experimental analysis to get objective data for the subjective issues. And then the main parts of the research is to build up this evaluation model for orientation and navigation. And then in the orientation, I defined the 3 sub-evaluation value, including the visibility, learnability, and the recognizability. In the navigation, also have 2 values, visibility maintaining ratio and the path deviation rate. So first is the variety evaluation model. To evaluate like how complex the space is, there are many factors can be evaluated. But in my scenario, I'm more focused on the measurement of the diversity of the destination. So I set up a customized algorithm based on the k-means cluster algorithm to define the different types of the space based on its geometric attributes. So in this way, to get the variety value of the space. So for example, from the left to right, you can see the variety value increases, which means the space is also getting complex in terms of the diversity criteria. And for the orientation part, including the 3 sub-values, first one is this visibility. There are also a lot of research and methods on how to measure it. But in my case, I'm more from a first-person view to measure it. And then for defining the visibility value, I set up the measurement workflow using Unity perception package for simulation and the Unity dataset insights package for the computing statistics. In the simulation scene, it's mainly to simulate from a human eye level point of view how people orientate themselves in the space. And then when run the simulation, it will generate random view images. Then based on the customized script, it will automatically calculate like how many times the target appear in the scene as well as the total pixel. So this means the higher the value, the more human can see the targets in the space. And then in the space in general is with high visibility. And the second value is called the learnability, which is a kind of to simulate how fast the human can recognize a new space. And for defining the learnability value, so I set up a measurement using the image segmentation training method in FastAI. After labeling the main architectural elements in the scene, the simulation is still based on the random these viewpoints in the scene to generate different view images, which is showing on the left, and then this semantic images is showing on the right. And then this is the example of the output. So then you can feed this simulation data into the FastAI training to get how long the machine needs to learn a space. So the longer training time means more difficult to learn. And the next one is this recognizability value. It's more like simulate how human will read the space. And then to define the recognizability value, also use the machine learning model. But instead of the time, how fast the machine can learn, it is about after learned, how accurate this machine can recognize the architectural element over the design feature. So like a kind of like a competent value over accuracy values. For example, whether it can recognize the escalator in a space. And then based on the above method, I developed a parametric atrium generator model as a prototype to test, with 12 different variety value of 34 design iterations. After generating the design iterations based on the sequenced variety values, the next is to run this simulation for the visibility test. So in total, there have like 170 simulations have been run, and then 17,000 view images have been generated. After mapping all the variety and the visibility value, we can kind of get this trade-off map showing on the left. This is also kind of verify the hypothesis in the beginning that the high variety will have low visibility value. Also in the mapping, we can see that each of the variety value, the visibility value is varied, which means we also can optimize or select the design that have both high diverse and high visibility. And then also for this 12 variety value design iterations, I also ran the learnability evaluation in FastAI. And then just to give an example, so the data shows when the variety value equals to 0, it only took 45 seconds for the machine to learn to recognize the architectural element. But compared to the high variety, such as when the value equals to 0.91, it took 151 seconds to learn. So this is also a graph to show they have this kind of a trade-off correlation between variety versus recognizability. But although it's not very like, the learnability. So although it's not very strong correlation compared to the previous one, it still showed the tendency. So the same way for the recognizability evaluation analysis model. And then this is the trade-off graph between the variety versus the recognizability. So according to the prototype test, already can see there have a strong correlation between variety versus the learnability, the visibility, and the recognizability. So the current prototype setup is relatively tailored to a particularly scenario, but by using this systematic tools, this methodological setup can be abstracted from a prototype to something more generic system for evaluating and optimizing this design. And then next, we'll quickly show one example how the methods can evaluate the design project. So this is a 6 floors cultural retail atrium in a podium complex. Here I have like a 2 different design approach. After meet all the functional program plan layouts, normally it depends on the architect to the experience or the aesthetic to pick a design option. But this method can provide a more quantified or scientific way to compare. And then this is an example of compare the recognizability value of the 2 design. And so this kind of illustrates how a trained neural network can be used to evaluate or to rank a series of design proposals on the basis of their recognizability. And also the evaluation process is quite simple. Just input a screenshot or rendering from the design space. It will output the recognizability value of the space. And lastly, I will just give a very quick glimpse of what I'm doing on the navigation part. So this is the visibility maintaining ratio to simulate during the navigation towards a darker, how frequent you can see the target. And then the higher visibility maintaining ratio, this means it's easy to navigate. And then this is like the second value of the path deviation rate. It's measure the efficiency of the wayfinding. And then this value also can help to evaluate or to optimize the navigability of the different design iterations. So besides building up all this evaluation model in parallel, I also doing empirical data collection, which will in the future help to calibrate the model and verify some of the hypotheses. So basically is to develop an online small game and then let people to play to see how real people will orientate and navigate in this space. So to conclude with defining all the different parameters, it is also can be generalized as a toolbox to evaluate the orientation and the navigation properties in the complex scenes. So therefore, this approach allows to optimize the design of the complex scenes in terms of the legibility. And from the theoretical aspect, based on the evaluation and the simulation model, the design variations can be scored, the legibility can be ranked. So we could learn together with the machine that what are the features and then the rules to make the things more legible. So then to find nearly the generating rule set to generate designs always with high legibility. And that's it. Thank you.
Thank you, Snow. We'll come back and have some questions at the end. That was great to see your latest work. We're going to move on to Virginia now. Virginia, I should say, is no stranger to China. She worked for Studio Zhupei, for some years. Zhupei is currently the, I think, the dean or the director of CAFA, the Central Academy of Fine Art in Beijing, the Department of Architecture there. Virginia, welcome.
Hi, so you can all hear me, yes?
Yeah, we can hear quite well.
See my screen now?
Yes.
Okay, perfect. So I'm Virginia. My advisor is Philip Yuan as part of this research at Tongji. And my research is focused on multiple knit materials for performance and membranes. And so I want to talk a little bit about knit very quickly, just to introduce you to the ideas that knit is very different than weaving because it has built-in elastic properties. So where a woven structure is made with 2 yarns, a warp yarn and a weft yarn. A knit structure is made out of continuous loops of yarn that is knitted by row. So each row is knit together, and it's a process of almost like additive manufacturing, layer by layer, row by row. And the yarn, because it's in these loop structures, can slide and slip a little bit and create some expansion and elasticity within the fabric. And there's a few different types of stitches that knit can make, with front stitches, back stitches, which if you're knitting by hand would be considered a knit and a purl. But in this case, because I'm machine knitting, we would consider that front bed or back bed. And then there's tucks and transfers and all these other kind of different characteristics. So there's ways to play with the material's structure built within. I've been working with stole knitting machines to program and design these knits, and using computational design to create these kind of patterns and program it in the stole knitting software. And I've also been working a lot with a hand knitting machine, where you can see each row by row the material is being added. But mostly my focus started to work towards looking at multiple materials and how these different materials interact or react to one another. So you can see here I have these materials when they're in a relaxed state versus a stretched state, and comparing different stripes of materials, how certain bands of fabric might begin to shrink or curl or have rigidity based on the use of elastic yarns, wire yarns, thicker or thinner yarns, cotton versus wool, and how those different materials react together. I've also been studying the elasticity to be able to understand how to begin to program and calculate for design at larger scales. And you can see here how those different elasticities can play out. That's something within a stripe of elastic yarn. When it's stretched, it looks just kind of like a normal striped knit, but then when you relax it, it has these kind of puckers and wrinkles as the one yarn is much more tighter than the other yarn and begins to wrinkle. You can see this kind of play with these materials as they stretch and expand and curl on one another. Also working with things like monofilament or fishing line, elastic yarns, because those monofilament yarns begin to create some rigidity or structure, so they don't curl, they don't soften, they become really hard edges, and those have different characteristics when they're pulled and stretched as well, and begin to wrinkle and curl in different ways. And this type of material research is then played into grasshopper simulations, where you can then begin to predict how certain curling or different measures of effects might happen based on an understanding and play with the material, and using kind of mesh frameworks to do that play, and getting these results that are kind of these wrinkly fabrics that are the same as that of the test models. So of course, those are just swatches and samples, and starting to look at how do I actually begin to create architecture or build out of these types of materials. So adding some sort of structure or framework to it. In this case, just a nylon rod was added to a piece of fabric, and it begins to stretch and pull in different ways. And you can see how certain parts of the stripe stretch more than others, depending on the way that it is shaped around the geometry. And here's just a detail of how the rod itself is actually embedded into the knit. So small holes were created by using transfer stitches to allow the rod to be connected to it, rather than adding another feature or trying to sew or tie it to the rod. It's actually built within the knit. Same thing here, another small model looking at that as well, and really looking at how when you have these models, they're quite playful, because there's this bounciness or quality of movement to it, which starts to question rigidity in architecture and the case for making architecture, which is softer and more flexible as a structural design. Working with textiles particularly, obviously is soft and flexible, but then working again with types of structural systems that are also flexible and allow for the material to move rather than perhaps your typical textile architecture that we think of, where it's maybe stressed to a full rigidity and you can no longer play with the tension of it. So these materials are really intended and explored as transformable, as manipulated and moving parts in the built, or proposing them to be moving parts within the built environment. And so that leads to the last thing that I'm going to present in the last few minutes, a few structural designs at a small scale, where I was looking at these tensegrity models using bending active rods, and particularly looking at this kind of pink one, where it's two C-shaped rods that don't touch each other, held in suspension with these pink fabric that was knitted to size. Which led to this larger structure, which stacks two of those modules on top of each other, creating this helix structure. And within this structure, the material, because it was scaled up, I didn't have a large enough knitting machine to knit it as one large panel, like the small model. So all the panels had to be broken down into sub-panels, which very beautifully begins to suggest how the tension across the larger panel is divided as the kind of apertures in between each of the panels begins to create these different size stretching, and you can really see the pull and direction that the fabric is being pulled in. But part of this was also looking at how the structure itself begins to wobble and move. So going back to that earlier statement of what is the rigidity of architecture and why does it need to be rigid, and looking at how our bodies and how our spaces could be interactive through these kind of flexibility and transformable forms, working with fabric and soft structural materials like these rods, and looking at how we can move through these types of spaces in the sense that you could begin to go inside and crawl and push on the fabric as you have to navigate through something that is more web-like or more light like this. And of course, this structure was extremely lightweight and easy to assemble with one person. These are just stills of that process of assembly, which took only a few minutes, maybe 15, 20 minutes, and the whole structure at the end was able to be lifted up and just placed. So it's quite an easy process. And then the last one I'm going to go over real quickly is also working with this kind of hyperbole shape, which is a lattice structure that can collapse and expand in a very easy way just by pinching. And you can see this kind of structure begins to expand and contract at different rates, and working with deploying some knit material to it so that these, where in the previous model rubber bands were holding those joints together, there are now holes within that knit material which holds all those sticks together and then is held together to make this kind of collapsing and expanding. And currently I am continuing to explore this design and add more features and make it even larger for the next steps. Thank you.
Thank you, Virginia. Next presentation will be from Marcus. Marcus Farr, I should say, was in China and also previously as a Fulbright scholar. Welcome, Marcus.
Yes, hi Neil, hi everyone. It's really nice to be here tonight. I'm excited to share the research with you. So my research focuses on sand, and for a few different reasons. Number one, the potential of dune sand material for architecture in the Middle East and North Africa region, where I currently live, where dune sand is a material found in extremely large quantities, but is not used as a local material. It looks at the global sand problem as a result of construction practices and articulates the differences between dune sand and construction sand and the behavior of that sand, such as self-organization and predictability. It presents a series of small studies in the tectonic potential of the material. And these studies act as small research projects or probes that have different methods and outcomes. The first series of images that I'll show tonight illustrate a global problem relative to the built environment and the background for this project. And there's a question of sand in all of them. Sand is the most consumed natural resource on the planet, besides air and water. Because of this, there are massive environmental impacts due to river and beach sand mining throughout Asia, throughout the world. This contributes to environmental devastation and social problems due to crime rings, mafias that control the mining of sand. The sand is then shipped thousands of miles around the world to build buildings in completely different regions, essentially destroying ecosystems in order to build buildings thousands of miles away outside of that context. This contributes to further carbon footprint and embodied energy and material. Yet it's estimated that only 5% of the world's sand is used for architecture. This is because marine sand and river sand are very different than dune sand, such as that found in the Sahara and Arabian deserts. Construction sand comes from rivers and beaches and mines. The largest deserts in the world contain dune sand, which is a different material and not used for construction. So for context, 41 billion tons of sand per year are needed for 4.1 billion tons of cement. So a huge percentage of the world's most desired construction resource cannot be used based upon current construction processes. This means there's an unsustainable relationship between the amount of sand that exists compared to the amount that we use for building. In desert cities, the relative proximity to so much unusable sand creates a striking contrast between resources and construction methods. The buildings here, for example, just like in other desert urban areas, require sand from Southeast Asia and Australia, even though they are surrounded by several million square miles of desert sand. This illuminates an opportunity and a problem in that modern cities cannot be made without sand. Concrete and glass and computer screens and asphalt, infrastructure, etc., all require sand that comes from the 5% that we currently mine. And yet dune sand in the Sahara and Arabia are currently not used as a building material. So the following research interests explore material development using dune sand as a local material resource for desert communities in the Middle East and North Africa regions. Dune sand is difficult to work with and cannot be used in concrete because of very specific reasons. Number one, it's round in shape. It stacks as marbles instead of triangles. It's very smooth as a surface finish because it's conditioned by air and not by water. The particle size of desert sand is very fine. They're slightly alkaline in nature, which also doesn't work for building materials, and it's very dense, similar to dirt. So as a result, relative to material, vernacular buildings in the Middle East are made instead of mud, shells, coral, manure, not dune sand. So we also find ancient examples such as this that carve into existing rock, but still far less. The conversation becomes about actually building with something that exists as an existing rock or stone or context rather than the sand material that surrounds it. So none of the primary elements in vernacular Middle Eastern architecture are made from the most widely available resource, which is dune sand. One of the biggest obstacles is that sand cannot be used without a binder. A large part of the work in this dissertation focuses on a series of material tests and material probes that speculate on the potential for dune sand to be used with different methods. Each of these are accompanied by their own process-specific chapter, illustrating the materially specific advantages and disadvantages. These probes include bacteria, calcium chloride, sodium thiosulfate, salt, tree sap resin, animal bones, soil stabilizers, and 3D printing resins. It was clear through these tests that 3 were more successful than others: sodium, salt, and soil stabilizers, along with 3D printing and casting. These were constructed as bricks and also as membranes, as tiles, and as screens. In these studies, the dune sand was always combined with only one binder. So I will explain only one of the material probes briefly today. This process focuses on sand's ability to self-organize and then be frozen with a stabilizing binder. When sand is piled on an articulated plane or limited plane, the shape of the plane can begin to affect the shape of the pile. For example, a round plane creates a different pile than a rectangular plane, and so on. When sand is poured onto a lifted plane and accompanied by openings, the sand pile's organization is affected based upon the opening and the proximity to an edge. This is because of the angle of repose and gravity. The critical threshold for sand is the angle of repose. The angle of repose varies depending on the size and the weight of the aggregate. For example, wheat is different than sand, gravel is different than sand. For desert sand, the repose is 34 degrees, and the complexity of sand piles begins there. Tiles of sand can be configured this way and have exactly the same result over and over and over again. With the sand pile machine, we can test various computational definitions that create points in specific locations and create very specific physical sand piles. Here, compared to the previous slide, the arrangement and sizes of the openings on the plane are different. The point placement, potentially openings for ventilation, and shadow densities are all associated with one another, as well as the depth of the sand pile and the weight of the sand pile. It is a dynamic field. More holes equal less weight, which is important because sand is a very heavy material. With more holes, there are more shadows. So next, the process was repeated, and a series of articulated planes were introduced as a contributing element, along with the self-organizing factors of the sand. The question here becomes, how can an articulated plane or series of planes be used to make specific tilings based upon those factors that could have a performative value? So here I am using parakeet and kangaroo to add to the workflow. These components focus on logarithmic pattern generation, and I can inform the articulated planes for the tests as a system. This also asks a potentially important question of how to standardize and fabricate a system using an isolated panel method and desert dune sand. Many variants of openings can be included in this grammar, both in terms of the number of points and the size of opening and location of the opening. The digital variants were fabricated physically, and sand was poured using the articulated plane method. The sand tiles are placed in a liquid bath underwater, essentially, and the binder hardens the tile. There was a total surface area of 4 feet by 8 feet constructed with this experiment and these tiles. The extension of that study incorporates Wallasey to begin optimizing the openings and the placement of points on the tiles based upon environmental data using Ladybug. This process uses highly detailed logarithmic clustering to assist in better understanding of evolutionary runs, including fitness values. This can help make more informed decisions at all stages of the sand pile design system as an evolutionary simulation, including setting up the design problem, analyzing the results, and selecting the desired solution for final output. Digitizing the sand provides the ability to select and reconstruct any phenotype from the population after completing a simulation. From this, I can achieve a greater understanding of an optimum condition using sand as a material, because the values are based on inputs that come directly from the material performance in response to data such as radiation and daylight, facade condition, wind, and thermal factors. I can also compare this against the same situation using concrete or brick or steel, for example. For example, in the objective space seen here, the target surface, we can evaluate minimum sunlight and minimum radiation inside of an evolutionary set. We can then ask to alter that. As we can see, the newer generations in orange are showing better results as they're closer to the objective. Distribution graphs show the fitness values. Initially, they start as red, which means the initial generation had a large range of fitness values. And then as the optimization continues, the blue distribution is being concentrated, which means that there exists an optimum solution. In the parallel coordinate plot, the more optimum solutions, which come in later generations, have good fitness values for both objectives. And this means that our fitness goals are not contradictory, and there can be a solution that meets more than one requirement. Here we can see the version best for sunlight and best for radiation, along with the best as an average condition. These were pulled from a large number of different evaluations. This is based on a relatively small number of hours and generation, less than 100, but can be increased to much, much more. So I took UAE weather data and sun trajectories selected around 500 hours from the year when the conditions were very hot, high temperature, high humidity, and low wind at the same time. The idea here is that sand dunes on the tiles created by the self-generated point grid may actually act as a shading devices by themselves. It was calculated the incident sunlight with flat panels with standard holes on the right and compared it to the one with the dunes on the left. And the result is that the dunes created by the holes on the tiles shaded 53% of the overall sunlight that was coming through in extremely hot times. So this is a particular workflow, and material probe provides an optimized version of the point cloud, no longer a static grid, and the result is very different. Here, finally, we can begin seeing the possibilities for optimized openings and panels made of sand. These are different phenotypes and solutions from that method and from that process. Finally, in conclusion, over the past 30 years, sand demand has grown 360%. The current ways we use sand exceeds the Earth's capacity to create more sand. Sand is made from natural erosion. The largest sand mine in the world is Pyong Lake in China. It mines 980,000 tons per day. Currently, construction projects in desert cities such as Dubai utilize sand imported from Australian beaches. There were 45,000 tons of sand imported for the Burj Khalifa alone. And this is not a critique of Dubai, as this is really a condition that is entrenched in our construction practices, but construction is not going to stop because our population growth will continue. The population in desert areas is expected to rise by 47% by 2100. And the work is trying to generate and survey information for how we can build in the desert with sand material, especially to impact local conditions. Thank you.
Thank you, Marcus. That's amazing. I'm always blown away by your research, and seeing those glimpses of the desert are always astonishing. So let's move on to Andrea. Andrea is actually from Brazil originally. I taught her some time ago in the SARC in the biodigital program, and she's also, as I say, trained as an architect, is also quite a successful product designer and a furniture designer who's won many awards at the Milan Design Fair. So, Andrea, I'd like to share your screen.
Yes, I'm sorry because I'm having an issue with my camera and PowerPoint, so I won't be able to open the camera now, but later without PowerPoint, hopefully I can. Well, can you see my screen?
Yes.
Yes, okay. So first, thank you, Neil, for the introduction. Hello, my name is Andrea Macruz, and my advisor is Neil Leach. My thesis is called Towards an Architecture of Homeostasis, How the Theories of Antonio Damasio Can Inform Design Thinking. This theoretical work aims to raise questions in the design field instead of providing objective truth or concrete answers. It has an epistemological approach rather than a scientific one. If we look to the hypothesis of the thesis is, could the theories of, I'm sorry, it's here. It's not, let me see here. So could the theories of the neuroscientist Antonio Damasio contribute to the design discourse? Here, the term design includes design, architecture, and urbanism, because these blurred identities help us to focus on the process and relationships rather than the result, and it stimulates new intersection between those disciplines. Contemporary neuroscience research, especially from the last 50 years, and rigorous methodology have supported the scientific validity of theories addressed in design. Damasio research has contributed to the understanding of affect in social cognition and decision-making. But besides all his research, Damasio homeostasis theory might be the most useful for design discourse. For him, homeostasis is a self-regulating process by which an organism can maintain internal stability while adjusting to changing internal and external conditions resulting in well-being. Feelings are the main contribution of Damasio to homeostasis theory because they can lead to a conscious homeostatic process. So the relevance of homeostasis and emotion is becoming evident in neuroscience, yet difficult to incorporate into design fields. Therefore, this thesis offers an opportunity in this line of research. How we feel can start to serve as homeostatic guides. Here, I will address three main questions. So the first one is, how might the theories of homeostasis contribute to understanding perception in design? Well, the process of consciousness can have a top-down approach, which starts with high cognition and goes down. Many neuroscientists and cognitive scientists, such as David Chalmers, use this approach. Another one is a top-down that begins with very humble homeostatic feelings and goes up. Damasio uses this one. So consciousness for him is minimalistic. It's a sense of ownership of the mind. Therefore, homeostatic feelings enable consciousness to the things that are co-experienced and overlay the possibility of consciousness to whatever we hear, see, taste, or touch. And according to Damasio, emotions and higher cognition processes don't contain intrinsic value, although they are usually labeled with valences generated from body states. They borrow them from the components of the homeostatic regulation. So rational choices and preference use the valence and intensity of feelings. Therefore, for Damasio, feelings are basic forms of cognition. He gives an example of normal people playing cards. If one deck of cards is not favorable, people tend to know it non-consciously before they know it rationally. As we know, perception is a mixture of interoception and exteroception. Interoception that produces feelings. Proprioception is when the body adapts to facilitate the best interaction possible with the environment. And exteroception that evolved later related to emotion. So the word emotion comes from motion. That is why exteroception is usually linked to proprioception, but not so much to interoception. And this is strange because before moving, the body must predict that motion. So Lisa Barrett points out that if my heartbeat goes up, my exteroceptive senses change, so they perceive differently. Also, the prediction my brain makes about a situation is not so rational because it doesn't have time to check if my past experience is informing me of the prediction that I'm getting at the moment. Therefore, interoception is very important And Youssef and Jeff Hawkins also talk about how these three components affect perception. It's possible to do a parallel with some well-known theories because for Damasio, perception includes not only receiving messages from the environment, but consists in acting on it. And according to Damasio's somatic maker hypothesis, emotions and behaviors profoundly affect decision-making, learning, attention, memory, reasoning, social functioning, and creativity. That is why Damasio affirms that humans are fundamentally emotional and social creatures. And Mulgrave complements that by saying, it's now apparent that we read out worldly perceptions through the filter of emotional values. Here are some points to consider related to design. First, what we feel and think about a design is biased because it depends on our mental processes, body states, and environment much more than we might consider. In this case, person and design may constantly exchange positions as subject and objects during an interaction. Second, extending Margaret Wolf's phrase, beauty is in the eye of the beholder, affective states regarding to a design might also start in the body of the beholder and what is capable to perceiving regarding interoproprial and exteroception. Third, what we think about a design may be different from what we feel about it. Moreover, what we feel about it could guide behavior non-consciously, so conscious choice may be insufficient to ensure beneficial behavior. And finally, fourth, designers could pay more attention to internal stimuli, how they affect what we perceive, and think if there is a way to influence interoceptive states, changing threshold to be more open to exteroceptive inputs, for example. And a design could emphasize embodiment, emotion, and social process to help with attention, learning, memory, etc. So the second question is, to what extent might design be seen as an extension of ourselves, acting as psychic stabilizers or destabilizers? According to Damasio, sad music, for instance, can become pleasurable if there is an ongoing homeostatic imbalance and if it was corrected. If it doesn't lead to a pleasurable response, it might mean that either no homeostatic imbalance was present or that the musical stimuli failed to correct the imbalance. As perception is not only based on exteroception, even said external stimuli may lead to a pleasurable response. In reality, homeostasis regulation can be understood through the interaction of these factors: personality, learned associations, and social context that contributes to a mood that leads to a pleasure response to sad music or a psychological rewards of sad music. And all of that is in a loop as one interferes with the other. Here are some points to consider related to design. First, design, like art, enables a range of emotions to be felt and communicated subtle without the use of language, and has the power to express, regulate, and amplify emotions. So it might assist an organism or even a group in achieving homeostatic equilibrium. Second, the affective state of a design may also be influenced by ongoing homeostatic regulation. In this case, the relationship between the personality, background, context, and mood may be more important than the individual and environmental elements that contribute to the enjoyment of a design. This diagram is based on Damasio's one about music, but translated to design. If a person has a neutral mood with a personality open to experience, said stimuli can lead to a pleasurable response because it could induce a variety of emotions, causing pleasure and experiencing an optimal state of well-being. Third, there are different thresholds to homeostatic feelings depending on the person or even for the same individual in different moments. Could design address ongoing homeostatic imbalance, physical and psychological? In other words, a homeostasis-based perspective to achieving well-being. And finally, the third question is, could designers use homeostatic feedback to create projects with greater intelligence and performance? According to Damasio, the conscious mind is composed of the mind and the self that is always felt. Therefore, you can see something and feel that you see. Also, there is not only one state of consciousness for each person. So in fact, he divides the self into three sectors: the proto-self, which is pre-conscious; the core self, for example, if I'm having a coffee at home; the autobiographical self, if I'm having a coffee in a coffee shop with many stimuli, talking to a friend about my past experiences. And there could be another level, an embodied sociality of thought that could be related to the extended consciousness on a collective level. So the first feedback loop is related to the autobiographical self. We have a lived past, a present up to date, an anticipated future, for example, making a plan for Christmas. They are in a loop and one changes the other. According to Evan Thompson, we are constantly rewriting the history of our past. I made a second diagram based on Damasio's idea, in which design and the conscious mind coexist. Design affects the mental construction of the conscious mind that affects back design. Therefore, subjectivity for Damasio might depend considerably on the changes in the boding states during and just before the object's perception, a state of self-evolving due to the organism response to the object. Relating that to design, Damasio's theory might show that design is never static. It is constantly updating itself, is different for every person because it depends on the self, and for the same person because of the updated mental construction and the fact that consciousness varies with circumstances. Finally, it depends on the individual, time, and environment. And regarding that, it's important to remember that we are the only species that, besides adapting to our environment, we change it drastically to better adapt to ourselves. So we can do a parallel here with the concept of autopoiesis by Maturana and Varela, in which systems continuously construct themselves and define their own relations to the environment. And Liu Lich's phrase, not only do we grow into and become part of the environment, but our environments become part of us. Time, therefore, becomes a significant factor and one which deserves to be integrated more fully into mainstream and architectural discourse. So also, could design be more interactive, making people more aware of its effects on it, which in turn affects people behavior that affects back design? And could we design for different states of consciousness? For instance, patients with Alzheimer's tend to remember the things that they are emotionally charged, such as their first house, native language, and etc. Could we use affective memory as emotional strategies to ground and empower them, helping them to use an object or navigate a space, focusing on their identity? And here again, we can relate to New's identity concepts, individual histories, and familiarity. Dr. Forlenza suggested that we can use the term affective functionality. And finally, feelings influence emotions. And nowadays, emotions started to be captured and measured to a certain extent by wearable technology and quantified self-practices. How could designers use any of this feedback to produce more intelligent and effective projects? So thank you very much. And this is my contact if anyone wants to talk about that further.
Thank you, Andrea. I don't know if everyone noticed, but the work that was being shown alongside that presentation was Andrea's own design work, which is exquisite, exquisite. We now move into the second part where I'm going to be introducing the Department of Design and Innovation. We've got two more PhD candidates from there, and then we'll have some questions at the end. So let me just share my screen again and introduce the Department of Design and Innovation. Literally over the road, this dialogue goes on between the School of Architecture and the Department of Design and Innovation, which actually, where many architects are actually professors, including Kostas, who of course is somewhat of an icon in the world of computational design. He is the author of 4 different very significant books and very early books on architecture and computation. And he taught previously at UCLA, at Harvard, and so on. And he's now a professor at Tongji University, the College of Design and Innovation. Kostas is actually in Japan right now, so he wasn't able to join us, but he recorded a brief introduction. So let me just play this quickly before I introduce our 2 remaining speakers. Oh, sorry, I should also start by saying that yes, I mentioned that Tongji in architecture was number 30 in the world. In design and innovation, it's number 12, even better. And it's the leading school in Asia. So you can see it. It's astonishing how these how Tongji is going up in the rankings, as it were, in both architecture and design and innovation. So here is Kostas.
Hello, everybody. My name is Kostas, and I am teaching in the College of Design and Innovation. I am the author of books in the area of design and computation. I've been involved with 3 projects right now. The one is called AI, which is basically AI art. About 2 years ago, the city of Shanghai gave us a factory to make it into an AI exclusive art center. And we took this challenge and we created this center of that actually incorporates an educational facility and also a laboratory for AI artists. So the first thing we did was to question the idea of AI art. What is it? And most importantly, who is the author? So we did a conference in 2021, which many people came, very famous and artists and theoreticians. I think Neil Leach was there too, I believe. And we basically went through a nice dialogue with to find out what AI art is. The show started on October of 2022, and it was well received. And this is the opening night with the people. And the next conference is this one here.
So, as we all know, of course, the AI is a huge topic in China, and we can see also, especially in Tongji University, with this new center established by Kostas, we've got something extraordinary happening, just beginning to happen, very new and very fresh. So let me then introduce our final 2 speakers. Neither of whom has work I've seen before, but it's great to have them here working with Kostas in design innovation, doing PhDs in the realm of AI. Let me start by saying a few words about Krid Jinklub, who is, in addition to doing his doctorate there, is also a cloud solutions architect and consultant for a number of startups. He's also a competitive programmer and has won a number of awards for that. He received his master's in software engineering at the Beijing Institute of Technology, where he won the Excellent Student Award. And he's been involved in giving lectures both in China and Thailand. Then Chen, also a PhD student in the College of Design and Innovation at Tongji, working also in the area of artificial intelligence. He's also a senior researcher at the Shanghai lab and the Sustainability AI lab at Tongji. And prior to this, he was a research intern at the Institute of Artificial Intelligence at Shanghai University in Beijing. He's won a number of awards for various contests, including mathematics and electronic design and obviously the world of AI. And he's the author of a number of technical publications, including a paper published in the Journal of Neural Networks. So I'm not quite sure who's going to go first, but let's say Krid, are you going to go first? Over to you. Let me stop sharing.
Thank you, Professor Neil. Can you see my screen?
Yes.
So say hi to everyone. My name is Krid Jinklub. As Professor Neil introduced me, I'm Thai student coming from Thailand, now studying with both Professor Kostas and Professor Filippo Frabocini. As been introduced, I coming from software engineering background. When I came into design field in Tongji University, there's a lot of liberation time for me. So I maybe introduce you guys, maybe you know about design, or maybe someone the same as me, never knew about design before. I would like to deliver some fresh perspective as I have a few years ago. But my dissertation here is in really early stage. So let's see. So apart from being student in Tongji University, in Thailand, I have been a little bit doing here and there in startup community. So it's about technical stuff, working with Google, going with the data science in National Brain Research Center, study master in Beijing Institute of Technology, and work in China for a few years as a chief architect. Corresponding to the course that I take in Tongji, right? It's all about AI, innovation, and design. Sometime when I have some question or some discussion with professors and my colleague, that's like a little bit of information that I need to research. Then about AI, about the author, as Professor Costa just say in the video, this is one of the, it's a bleeding edge of the research, because nowadays there is many AI that produce images from the text as a sentimental. At the end, who is the right author, right? As the code, you can going back through the source code there. There's many legal issue there, copyright, copyleft, the law that implement in many countries. In China, for example, the rule of law is different. And when the art of design and AI can be combined, it had been represented through the history since the beginning of the computer generated design, or even some kind of like sustainability that has been produced and introduced by United Nations. So here is some talks that I have done when I was in Tongji University. Then, as Professor Costa already introduced, like we have been collaborated with Shanghai government in order to exhibit some kind of like AI specific exhibition There, I have been working with artists in order to develop and co-design the AI art piece. In that moment, I have realized that the normal gallery, the traditional gallery, need to have some kind of like redesign or restructure of the infrastructure in the case that they would like to exhibit something like this. And this thing is like a gap of research. There need to be a lot of research, like how to plan or how to design this kind of facility in the future. And as Professor Kostas said, this is premiered there and is quite well received. So what I say earlier about the fresh perspective, right? As the name say, I study in the College of Design and Innovation, right? So I would like to start with innovation, but where is the influence of design in this all of the innovation categories? You can say like this: disruptive, architectural, routine, radical things. But in all of them, there are some subtle process there. Design is in everywhere between the lines. Something like open source software, you need some design, some pattern. Video on demand, you have some kind of software architecture design, how to streaming things and have something to improve over time. And something even going down to the basic research, where you need to have something like, for example, the pharmaceutical company, how to create the biotechnology. This thing has been developed even like before the care of the word design. Actually, when at the beginning, right, design is just coming from applied art, started from Bauhaus school in like 19th century, but it's evolved over time. Here in Design and Innovation School, as I have been taught and I have feel about how the higher design education would like, it's like, okay, we try to set some stage in order to make the things to become the subject matter studies. So at the end, people can start going on about it and have some center point of gathering information. Then the things start to rolling over and over. Now we have a lot of things about design process, design methodologies, and even some kind of like design theories that can explain things that in the domain expert didn't quite, to be honest, like to be really empathized about. For example, like the engineer problem, they focus on the object optimization and result or even performance. But sometimes the context of the problem oftenly excluded some kind of social problem, people, and someone who working around the operation. So design is starting to get some attention from people to look at this specific problem by trying to define more and more of the design details. Here is something that corresponding to our previous speaker, like when we try to move the things in the society, right? It's making from society, gaining the knowledge, using technology as a tool, then it costs something, then it's gonna affect the things that society has been. This thing is like, it's a dynamic society, but in other words, it's social learning, where I have conducted some experiment with Professor Filippo in Shanghai summer school in this summer. Turn out like when you try to create the sustainable campus, the social learning is the core element that cannot be left out when we try to make the things sustain and be more anticipated with people. Before, right? So we now seeing that everything is like dynamically evolved over time by the technology as a tool driven things, cause the society to adapt and change. Whenever you try to design the activities, right? Nowadays, it's collective computing era. That means like the things is not simple as before. Even research, right? Before in like 40 years ago, the research is much simpler. But now when everything has much more rich in the term of the knowledge, you need some kind of like method or some kind of like guides, something to assist you to research the things. And here is the concept of the co-exploration, where you have been in a complex system, society as a lab. So when you address this kind of problem, you have known like now the co-exploration can be essential in the current era of design innovation and studies. So my research idea, as I've been senior researcher in sustainable AI lab. So my core idea is like, how can we make use of some concept that has been well studied in artificial intelligence study to improve our natural intelligence in sustainable way. I believe there's Andrea, right, has a question like, how can we improve the things based on our previous course of design? But that thing needs to be collective, right? So as a figure here, it's all begin from the human-centric. Everybody have their own experience without any context, but it started to be converged to some kind of like co-exploratory step. And this thing is when people start to recognize the pattern recognition about design. And this thing can be passed down as the next generation to learn what is design and what is for. So my research idea here is like, I use two theory. The first one is the hierarchical design theory, where you have many layers from the conceptual to lexical things as the NFT. NFT here is not only non-fungible token, but it is the smart collectibles, where it's trying to contain and answer to the problem of the reproducibility and redundancy, which is some kind of like the trending problem even for, let's say, some medical image processing. Like this thing need to be transparent, and the smart collectible is one of the answer. Use NFT to enable the co-exploration for the distributed cognitive system. Distributed cognitive, this is another theory that has been taught in very early days, but the concept is like, okay, when you try to design things, the feeling, the cognitive feeling can be distributed from the people to the object to the system. So I laid out some research question here, like how semantic creation of the design process as smart collectibles can influence the design community. Therefore, it could be improved, right, over time, right? The next question, like how does semantics protocol, the semantic web there, in a smart collectible scale the design production? Actually, design is a very fundamental things that can be extended. For example, like doctor can be considered as designer, right? When the doctor seen the problem, then he or she need to design some solution to tackle that problem. So design can be scaled to any expertise with the expert system. My hypothesis is like designers and next generation designers that interact with the design semantic network will incrementally complete the design challenge and be inspired by a priority design task and process. So if this thing or the hypothesis is true, the main thing that I would address in my dissertation is the consensus algorithm for this design or semantic network. Because at the end, the main problem is still lie there, like how can we trust and how can we understand the process of the design without being so decentralized in the context. So this is the brief research idea and the preliminary research for me. Thank you.
Thanks, Krid. So, Dian, with the final presentation today, then we'll have some questions. Dian, would you like to share your screen? Dian, you're muted.
Thank you, Neil, for the introduction, and hello, everyone. I am Chen Duan. My report is about self-replicating AI and generative art, with a subtitle, Can a Self Understand Itself? Which is a hypothesis that we intend to prove or disprove. Our research is at an early stage. Let's look at the subject of this hypothesis, self. To understand what it means, I used the Google embedding projector to get the most relevant 100 words, in which there are words like individual, essential, continuing, fighting, physical, mental, and interesting enough, machine, and creative. We use computer programs to test this hypothesis, in which case the machine may have its own self rather than the human self. In order to distinguish between these two different selves, we choose the specific field of AI art, in which the human presence gradually becomes less and less relevant. Let's take a look at the state-of-the-art methods. Diffusion models learn the representation of the appearance of what we see and can be better than what we see. GPT-3 learns from a large human corpus, thus learning human interpretation. Codex is its descendant for generating code. ImageGen is conditioned on large model, language model to direct the image generating process. But sometimes the appearance is deceiving and not essential. We intend to generate artworks directly from code. Then let's look at the predicate. The self becomes the input of its own. The subject becomes the object. This reminds us of an ancient symbol, Ouroboros, depicting a serpent or dragon eating its own tail. We have thus identified three key elements in our system: art, code, and a feedback loop. There are different computational models out there. Neural networks suffer from the problem of black box. Self-replicating cellular automata has no direct link to visual art. At the end, we choose the Piet programming language. It's designed in the principle that program code can be in the form of abstract art. Here are different Piet programs for artistic expression and scientific calculation. Its language concepts consist of color palette, codel, which is an analog of pixel, color block, which is a basic unit of Piet code. On the right, I put more or less their equivalent in the Python language. It maintains a stack for storing numbers. It defines its rule for execution flow and program boundary. It also defines numbers by the size of color blocks and various commands based on the difference of color blocks. Basically, the interpretation of how it looked like. Then the system we build is illustrated in the following diagram. We build a Piet interpreter for interpreting Piet program and obtain the instructions, and build the Piet generator to take in these instructions to produce images. On the top of the diagram shows our Piet module take input from codecs by converting, for example, Python to Piet language in such a way that we could potentially benefit from the availability of large corpus of existing code. And since the generated images may be quite hard for human interpretation, we feed the images to OpenAI outpainting to simulate human interpretation. Our feedback loop currently consists in the interaction between the interpreter and generator. We add some redundant instructions as noise to change the execution trajectory of the code to introduce randomness. We build a platform to execute Piet program. To generate Piet images. Add randomness to it. And finally, the feedback loop, which is self-replication in our work. We then input the Hello World program to OpenAI outpainting and set prompt as, could you please tell me what does this image look like? In order to elicit the artificial imagination. Then OpenAI outpainting fills in the rest pixels. We experimented different sizes and initial positions of this Piet Hello World program. Here are some outcomes. The future work consists in optimizing the feedback loop workflow and put our program or our agent into different environments. For example, we currently rely on existing OpenAI model. We intend to train it ourselves. And secondly, extend self-replicating application scenarios beyond its original field, artificial life. For example, think about two persons sharing memories. It may be interpreted as a self-replicating between these two persons. And thanks for your attention.
Thank you, Krid. That was great, fascinating. I mean, it's amazing to see what Kostas is setting up over there. So maybe if you can unshare your screen, we can now go into a series of discussions. I mean, just to say that if anyone's got any questions on YouTube and Bilibili, can they please send them in, and we can ask them here. I'd like also to bring Patrik in for this, but maybe before Patrik, I could just simply sort of ask her to kick things off with a general question. I think what is could you maybe? I think one of the things that comes across, of course, the international program, everybody is kind of doing something else alongside this, mainly in an academic post, and but some, obviously, in case of Snow, working in an office. and Krid also working alongside his PhD research elsewhere. So we have a kind of interesting kind of model. And just to say, this is like the fifth of the series that we have. We started off with MIT Media Lab, we had ICD Stuttgart, we had ETH Zurich, and we had UCL Bartlett. And it seems to be that each one has a different kind of, in a way, nature and way of operating. And I think what is interesting about this particular program is first how incredibly international it is, certainly for the international section, but secondly, also the way that it kind of goes hand in hand with, in many cases, an academic post. And I guess the question is really is how are we sort of shifting? Because it seems to me increasingly that doctorates are becoming a kind of expectation as in the job market. Certainly, I've been on the FIU search committee just recently, and we don't even consider anyone who hasn't got a PhD. This is for a post in history. Maybe for design, it's a little different, but it's becoming very clear that PhDs are becoming essential in many ways. In fact, in certain countries, and that includes China, and I think Australia, Serbia, and no doubt many more, it's written into law. You have to have a PhD before you can take up a professorial appointment. So I just wanted to kind of like raise that sort of question to those for kind of comments in some ways about the need for PhDs. It's become a kind of increasingly in demand, and maybe we're in a kind of transitional stage right now where we do have those professorial appointments without a PhD, but increasingly needing those things. So maybe, what is why do a PhD at this particular stage? And how do you see the world shifting in terms of the academic world in particular for the need for a PhD for any form of academic appointment? So maybe I could just kind of raise that question and invite some comments from our contributors today.
Well, I can start commenting on that, Neil. In my school, it was not necessary, but now the government is demanding that every professor has a PhD. So here in Dubai, it's like that, and also in Brazil, more and more you have to have a PhD in academia. And it's important as well when you get the PhD to be advisor of PhD students, because it's also computed. So here is like that.
I mean, that's actually raises a problem for me, because if you imagine every single teacher of architecture having a PhD, I'm very skeptical about the quality of these PhDs, by the way. So I've been very extremely selective always, and have done a few. I've completed 3 only in my life now as a PhD supervisor. And for me, the role of the PhD is incredibly important, though. Still, basically, what I've discovered, it's a very important intermediate step. And I mean, we have a number of them also in the office, between what you can try to do in a master degree course in terms of opening up research questions, exploring opportunities and illustrations, and then if there is kind of real innovation required in terms of developing tools, developing also underlying conceptions and arguments, PhD is great. Something you can do here, which you cannot do with a master degree program. You can do something similar in research departments, which we have, and we have a number of research groups in the company right now, but that's very, very rare and not available. So the university have an important role to play, and but also been using PhDs as an interim between the professional research teams fully dedicated and opening up research topics and utilizing on the one hand the resource and time and energy of PhD students, but usually also around grant programs. and I think that has been very, very important. And so I mean, if you look at AADRL, it's been incredibly important, but some of the themes which we then had to push beyond into the PhD level to study. And Snow is also an example of that. It's something I've been talking about and illustrating and to kind of deepen it and build a set of tools, operationalizing intuitions and ideas and understandings. It's incredibly important. But I think it takes a lot out of a student. oftentimes the allocated time I've seen with the Vienna students, I had a group of 6, 3 are finished now, and my tenure, which had already been extended, is finished. So it's people over underestimate it often what it takes as well. So, but I think Tongji has a very, very strong team. And if I look at the 2 contributions from Kostas, I mean, it's in its infancy and maybe shouldn't even presented that. I wonder why Kostas might shying away for being here, because I don't think that, you know, you're just getting up, you're just throwing up brainstorming topics. And if I would critique you, I don't think you have a research question or research theme. So I'll be quite brutal with you. So it takes a bit more to get there. I think we should keep the bar high when it comes to PhD research and what counts as it. So I don't want to discourage you. I think there's been some interesting tools you're talking about, some interesting topic and phrases and world you're entering, but you're nowhere near to formulating a PhD thesis. Just my idea. But let's say maybe that's, don't take it as an insult. Take it as a kind of encouraging kick in the ass, in inverted commas. And I mean, I would like to see what happens out of this. I mean, I'm fascinated with this new institution and conferences and exhibitions you have, but a PhD is another thing altogether.
Yeah, I would comment something, Neil, as well. I think relative to what Patrik is saying, you know, Patrik's office is a kind of model for how advanced education could be utilized in practice. I would say that not as many practices are doing that. So in some ways, it's a kind of laying the ground for a kind of blend of academic research and professional practice research, and how those two can start to create more informed work, but and better work and more exciting, more in depth. And I would also say, like, the use of the computing that is happening at that office, like coding in particular, and these kinds of things are quite exciting that I don't see in other offices. For me personally, I mean, I see a PhD as an opportunity to go in depth into one particular subject. You know, sometimes architects are seen as having a really wide knowledge base, but not particularly deep as compared to someone like an engineer. Engineer has a more specific knowledge base, but it's very, very deep. And so it gives the architect a way to go deep into one particular subject, and then, you know, coming back into teaching that, being able to communicate that subject matter to to undergrads or to graduate students, I think is valuable. And also, you know, it's also something that's individual. Whereas a lot of master's programs nowadays are, you know, they feature a lot of group work, like three or four students at a time producing research. So I see it as a kind of individual endeavor.
Yeah. Did you have any comments from the others? Maybe I could just pick up on one particular point, which is Snow was a student at the AADRL, if I recall correctly. And that's actually, you probably don't know this, but the history of things is actually quite significant, in the sense that I was teaching at the AA a while back, and I had a lot of students who graduated from the AADRL who wanted to go and do a doctorate. The only avenue at the time really was the London Consortium, which was a very good program. Mark Cousins helped to set up, sadly no longer running, but it was humanities-based. And there was really nothing for somebody from the AADRL to go on and do. And I think what is so significant is we have in academia now two models of a master's program. One is that the AADRL, MTech, and there are many other sort of programs, BPro and so on, where there's a kind of very specialized, often post-professional research undertaken. And then there's another one, which is basically where you could probably sort of say there's been some kind of inflation to the typical degree, or rather deflation of the master's thing, whereby almost many schools are just offering master's degrees, which are essentially kind of bachelor degrees, kind of just a bit slightly extended. So there are two models of the master's where you get the kind of generic one, and then the specialized one. And I think that specialized one is the important thing. And what I noticed with the AADRL is that in that space of, was 18 months or 15 months, the amount of work that was done, that was generated, was extraordinary. It was a huge output, and yet nowhere to take it. And it strikes me, well, the interesting kind of question is, what is the relationship between these specialized master's programs and a PhD? Because typically in the past, you actually could get into a PhD by doing a master's first. Certainly University of Cambridge, you could do that, and you were sort of shifted into a PhD if you managed to reach a certain sort of standard. So it's a kind of interesting kind of model. Actually, the FIU one, which we'll talk about in a few weeks' time, we actually take that into account. You actually take 15 credits from the master's and treat it towards the PhD. But in a way, the real challenge maybe for architecture is the fact that there are very few funded places for these PhDs compared to, say, other disciplines. But it seems to be an increasing requirement. So
I think that's a problem. I mean, I think Tongji is great in a sense. They set the bar so high. I mean, to get in, you have to have 3 published articles in reputed papers, and that shows that you actually have the metal and you build up towards a kind of scholarly mindset, a scientific way of working, and then you build on that and deepen that and make a full work. And so I think that's more healthy. I've seen too many PhDs who have to do it, want to do it. They see it as a kind of catch up, and they're not inherently scholarly or inherently scientific. And I think that oftentimes it takes out 3-4 years out of their career, which is frankly a waste of time. Maybe they have a title out of this, which maybe they can't fully utilize. I mean, it's okay with the teacher. You can teach. I mean, but you could have maybe. I don't think it necessarily improves your teaching. There's too many architectural teachers, and if they couldn't all be caliber of fruitfully engaging PhD work. And that's why I think the individual work is particularly very, very dangerous. I've seen it too many times. In teams, in groups, in research groups, it's much more viable, and it's more of a, because it's nearly more like the taught PhD, mutual teaching and agenda setting. I think there you can absorb more than you would be able to absorb, let's say, productively with individuals. And I think so. Yeah, I mean, it is my personal opinion. I do worry if there's too many, if that becomes too much a requirement and takes 3-4 years, sometimes 5 out of somebody's life and career development. I mean, of course, then oftentimes teach while they're doing this. And that means oftentimes a huge distraction. So then it takes 8 years to finish. So there's a number of dilemmas, which I think we can allow this to be pushed into a very large percentage of architects. I mean, I know it in the medical profession, everybody has a doctor, but I tell you, the scientific quality of what goes for a doctor in with every medical is, isn't. It means very little compared to the PhD standards which are upheld elsewhere. So that wouldn't be. I don't know. It's this kind of mentality of promoting measures and numbers on universities that have to increase numbers and so on. But it's a very let's say it's a double-edged kind of thing. I think, and I mean, of course, I get a lot of people coming to me with their proposals, and I've been kind of, unfortunately, discouraging most of them. But I think, but again, at the same time, I really think it's been incredibly productive with the 3 very high caliber PhDs I finished, recently, and this was also something which was built on years of edging towards and wanting to do more than what we were able to do at DRL or in an office setting. And it really was worthwhile, but I mean, people like Robert Neumeier, who, and Sung Min, who have been, of course, they're not kind of coming out of a fresh graduate saying I top it up with a PhD. It's quite a different thing. I think it's quite a different. Anyway, so. It's great to have the conversation, and you know, if I wasn't, I mean, it's a very crucial mechanism, and I want, I mean, I'm sure there are a lot of people out there who have, you know, published and have scholarly skills and scientific skills, and there might be already, yeah, to bring them into a program like Tongji, in particular now with that, you could be anywhere, right? I mean, eventually we might have to kind of sometimes reappear in Shanghai, but what was, you know, the reach of Digital Futures and the consortium and the forum, it's been amazing. So I don't know. I think this program, with its global reach, would find those, let's say, this 1% or whatever percentage that is, to come together. That's what I wish for. So I'm also stand ready soon to have pick up two more.
So just, I mean, I think we should just
can jump on this.
Okay,
Yeah,
so can I just, okay, go ahead, sir. Yeah, go ahead.
Yeah, sorry. Yeah, I think it's for just to follow up for this Tongji, like this special international PhD program is quite it's quite special. Like for example, maybe back to the 2019, I still like a fly back and forth in London and Shanghai, but also for this online course and all these digital future platforms, you can bring all this brilliant mind, and then you can have like, even like in this digital future workshop in the summer, have 24 hours non-stop, all this sharing. And I think it's all because of this openness. And also for me, myself, this PhD, because I graduated from a DRS mentioned by Neil Lich, it's also a very special master program. Actually, I would say it's like you already have halfway to this PhD. It's very intensive. And also you have this a group of 4, you always like, you fight with each other and like you argue to find what's the best way to drive your research. It's a kind of like a design-based research, but you also need to develop a kind of a new methodology to really like to push the boundaries. And then after like working in this practice, actually I think it's like a more research embedded practice. It's always have this spirit of pushing the boundaries. That's why also for me, myself, I would like to also go further in this discipline to pursue more. It's not only about to get entrance tickets to this like academia or the university. It's more about like we want to explore more, we want to go deep. And also because now I'm half practice and half research, is also can give each other like the new ideas, and then to hybrid these two. I think is also for this Tongji international program, is very good opportunities, and also can see from all the researchers from all over the world.
Just maybe I should just mention the fact that if anyone is interested in the PhD at Tongji, the deadline for Chinese students is in December, and you can find all about that on the Tongji website. For the international students, it's apparently in March. And if anyone has any questions about that, I think probably the best thing to do is to send them to info@digitalfutures.world, and we can forward the email to the person in charge. I should say that I'm also an advisory professor at Tongji, and I'm also open to some new applications, particularly as some of these are coming close to their end, both from Chinese students and also from international sort of students. Maybe I could just pick up on something else though. So on the one hand, there are these kind of the need, perceived need or whatever to have PhDs as academics. And I think I would say that beyond the actual appointment, quite often, this is the reason why I took my PhD, you end up finding yourself kind of putting an application for funding, and there's a little box saying, where did you get your PhD? You can't tick that box, and you're out the first hurdle. So I do think there are various incentives for doing that, and of course I fully subscribe to what Patrik's saying, that there is a danger that I think the PhD degree could be watered down in the same way that frankly the master's degree has been watered down because it's there everywhere over the world. But I wanted to ask Andrea a question, because Andrea is, although she is teaching now in UAE, primarily a kind of designer. And I think what is so interesting about Andrea's work is that And you saw in her presentation, but I don't know if you noticed it, but the work that she was showing was her own work. And it strikes me there is another model there, which is to say, getting into into some theoretical reflections, in this case, neuroscience, which I think is really a hot topic right now, as a way of kind of reflecting or trying to understand the kind of work that you're producing and the impulses that are behind your own work. So maybe, Andrea, you could say something about that.
No, you're totally right, Neil. And for me, I started this PhD because I was working for 10 years. And I was just working in the office, in the studio. And you, at a point, you don't think so much about theories. You have a limited time. You have to be more commercial. So the PhD for me was a breath of air to stop and to think about some theories and things that are happening that I thought that were important, especially because you can't keep up, with all the things that are happening. So it's a time for you to stop, to study, to really go deep into one subject. So in that sense was really interesting. And now in the future, I think I will really change my perception regarding to what I was doing. I think it's really interesting because after my PhD is theoretical, but after the PhD, I want to go to practice again. And if I practice, I will have a completely different view from what I was doing as an evolution of that work, and this, I think it's very nice.
I think Andrea's work is definitely like the prime example of this, where she's really focused on the theory portion, but it is related to her prior making. But I think even those of us that are making, there still is a lot of theory. I think I've experienced a lot of the same things that prior to starting the PhD, I was just making maybe for a client or for my own sort of proposals, and not really stepping back and looking at the overall theory and goals of why I was making, what were the results and responses from that making. And so the PhD has really given that time to read a lot more and focus back into that, and then define a sort of hypothesis and research agenda that the making I was doing is now integrated and directed towards. I think I can see that also with some of the work that Marcus has been doing as well, and even Snow and others, that there's this process of doing things, but also reflecting on them much more than perhaps before.
Yeah, I think what I find important is unhealthy. Let's say if you do a theory course and you engage, you learn a lot about the architectural theory, contemporary, let's say social theories feed into architectural theory. In the PhD, what we always see, the way we always critique it internally, is to find a way of narrowing it down in a way that becomes also has pragmatic innovation potential, right? So theory is, of course, connected up towards guiding innovative practice, and the way in Tongji in particular, but also the way we've done it in Vienna, the focus was what I found very productive too. So you have a set of practical engagements and goals, and you want to systematize. So you're thinking a lot of methodology, but then it doesn't stay there. It really moves on to tool development as well, and therefore then oftentimes analytical tools, but then also often generative tools, but now informed this just as really innovative, high performance design outcomes. And I mean, that's what Philip has always been emphasizing, that. And I think that's quite productive. So when I want to say something constructive with respect to Krid and Duan. So in our culture of critiquing a PhD, it's you can't stay, let's say the super high flying ambitions at the beginning. You need to find a way to dissect that and shake that, and when you explore a world, you find your way, which more modestly of of contributing a particular innovation, and even somebody like, and then kind of operationalizing that. So if you're talking about, I mean, it's amazing, this idea, you know, self-understanding AI, or when can we understand ourselves, these kind of philosophical ambitions, and then you kind of slip it into self replicating, but then it's actually more of a kind of model replication within a software rather than the replication of the software itself. So you're going to be on a slippery slope. So it's better to, and even I must mention this, even somebody like, you know, an absolute pioneer and let's say core protagonist of discipline, Shanghai Bushan, and I'm proud that he is at the same time leading the Code computational design group for 15 years. He is just completing his PhD with Philip Block, and if you look at it, it's narrowed down to something very specific, because it's a big field he's entering. It is a lot of he's building on and receiving, and it's not about replicating this or making and then contributing specifically with a new set of tools and methodologies, which generalizes some of the things which Philip Block, for instance, have done and what Code has done. So it's very helpful actually to look at paradigm PhDs. So you know, so I mean, I think I'm very proud of the 3 PhDs I completed at Vienna. They're accessible there, but also Shaj's done that. I mean, there's some key. If you look at typical important PhDs, even if they were done 15 years ago, like the one of Axel Kilian, they're still great paradigms. So you know what a PhD might look like, and particularly the two of you, you're working in the domain of computational design and picking up a new exciting domain like AI, and you have to find the architecturally specific programmatic and where this you can contribute, because that field is vast. I mean, it's and you have the history and you have the skills. So the way we're brutal with narrowing PhDs down to a point. And I think you're probably, I'm sure you will go through this. So that, of course, is totally unfair. We have here, we're looking at work which has been maturing for I don't know how many years now, 2 years, 2.5 years at least, and you are probably two months out of the gate, right? So, but I think you're onto something. Some of the what I've seen with Pete, this kind of visual programming language, or this whole idea of these kind of semantic networks and trying to marry that somehow with consensus mechanism. I don't know what that means. These are just kind of, at the moment, they're kind of, you're throwing things out there, which is suggestive, but I would say find a paradigm PhD, or it might be a white paper or for particular startup company, because they're theoretical, and I find them very good models. If you look at a lot of the crypto white papers, because they have a vision, they have radical innovation, but they also have steps and processes and definitions and foreseeing tangible outcomes. So there's another category, I think, of particular, because I think Krid is has been looking at AI and NFT intersection and so on, and you should look. I mean, I think the PhD is very similar to. I mean, PhD is deeper and longer, and more elaborate than white papers. But let's say the executive summary of the PhD could be condensed into a white paper. I'm just saying this because I'm teaching at the moment with somebody else. A big hangover from remember the European graduate school, Neil? I don't know if you still have. I still have one student. And basically what we're doing, we're going to do basically a PhD as the Lieberland Metaverse white paper, but extended with layers of, as a skeleton. So anyway, I want to push that out with help. I mean, do something, constructive critique for Krid and Dian, if you allow me to.
So just before I wanted Krid and Dian to kind of respond to something, can I simply just say one thing, that actually, in terms of the genealogy, shall we say, of PhDs, the one that we set up in the European Graduate School, which sadly, owing to a change of dean who was not sympathetic, shall we say, to our aims, did not progress anymore. I mean, you can still do on there, but you can't do it in this kind of specialist area of digital design as it was. But what this was the model that led into the Tongji model, and actually it's since other models, the FIUD has come out of that. But what we discovered in terms of the EGS was precisely people like Daniela, really quite high caliber individuals who were in need of a PhD. That was the market. We could see there was a market there, and in a sense, this is what we then took it from the mountains to the city. Now it's on the beach as well. But that model is quite an important one. But there's just a kind of comment on this question. I mean, I'm actually very excited by what Kostas has set up there. I think it's got real potential, and I'm really looking forward to seeing what Duan and Krid really come up with. But the challenge, of course, with a PhD, is, as you say, is really trying to narrow it down. I mean, I always think that kind of you start the first year, you write essays about modernism, the Renaissance, all these big topics, and the further you go through, the more precise you have to come. And I often use this example, which is a bit of a banal example, almost like the ideal PhD is to do a kind of PhD looking at the production of a certain ceramic tile in a Spanish town between the years 1865 and 1867. Really precise, and the more precise you can make it, the more focused you can do it. But that then presupposes the question about what is the topic. And I think the real challenge when you get into a PhD is kind of being able to define that, because in some ways, if you know already what you want to do, then what are you learning from your PhD? And it's got to be this kind of voyage of discovery. At the same time, you've got to put down some kind of marker. You've got to sort of define in some way, even though it's maybe a definition or an area that's going to evolve and over time and progress. But trying to fix that down early on, so you don't spend typically. What used to happen in the past, certainly Cambridge, when I was in Cambridge, the University Library was full of these PhD students who have been doing a PhD for 10 years, sometimes for 20 years. And now we have to try and make sure we complete them in 3 to 5 years maximum and so on. So it's a real challenge, but defining that thing at the same time leaving it open is really the interesting kind of thing. So maybe I can invite Krid or Duan to respond in some way to what Patrik and I have just said about the PhD. Krid.
Yes. Like, for example, right, normally, right, when people graduate from bachelor degree, some will go into the market, like some work, some will go directly to the master degree. And then after one graduated, they're going to work, and some may continue to work in the PhD. Therefore, there are some contradictory here. Like some say, if you work or you study in the PhD, you lack of the working experience. Right, but actually, in my point of view, PhD is the combination between the level of practice and the level of theory. But at the end of the day, if you graduate PhD, right, you should be able to apply those knowledge that you accumulated over the years to the level of the practice. It's not just like the over theory. Then, as I stated in my profile, right, I have worked before, then I came to the PhD. As Professor Patrik say, like people who just kept studying and maybe just like lost the way, like you just three months over the gate. The point is like, okay, maybe our point of view is much narrow as it should be. It could be broadened by, as you say, the Tongji is very great place to broaden this point of view. Like, okay, before it's engineer, now it's interdisciplinary as designer and more. So in my point of view, it's like, this is very crucial point when people try to decide their future work life, whether they're gonna bring more the theoretical things and or just staying in the working way of life, like not wasting like 4 years or 5 years, as Professor Patrik say. But I think it's interesting to broaden the view.
DGM, would you like to say something?
Yes, please.
Thanks, Neil. Thanks, Patrik. Thanks for your suggestions. I think for me, the PhD study is like I fix a problem that is quite hard to solve, and my PhD study is a start point of my future life of this problem. Of course, I need to also narrow down my scope and to find a specific area in this broad area to contribute to. And I think during these like 4 or 5 years of PhD study, the technologies evolves, and the technology of 5 years ago may not apply in current environment. And what's important in PhD study is like more of a training of thought, of theories, of like philosophical that side of training. So yes.
Well, I think it's also in the end, yes, you absorb that, but if you at the same time create and build a thesis, build a methodology of developing the thesis, etc., that's very helpful, I think. So in this sense, it's not only theoretical study. You will do your readings, of course, and you will your literature review, and you have your key references, and so on and so forth. That's where you start, and I think that's the stage that you're in. And but eventually, I think it's very healthy to generate, and you put it quite right. I think this could be and often is, the mapping out, ideally, the career you keep investing in and make a mark in the world, because there's a chance here to create something innovative, which you can truly own, and that shouldn't be, and that should be the goal, and that requires that commitment, and it requires that you don't take shortcuts. So yeah, I think that's well put. But I would say don't worry about what you're creating will be overtaken and obsolete. That's precisely great if somebody steps on your shoulder and goes beyond. But creating making a step in the collective trajectory of innovation that's the important part. Not only being an observer, but being that's the difference from to be a contributor, and don't really gear yourself to that that this work will be published, and you will do that in the interim. You will I think Krid always said you will be at conferences and lecture, or you will have the PhD is a large piece of work, so you can split off a number of smaller papers, and that's very important, because this will discipline you, and you will see what other protagonists present and what is respected and accepted, for instance, in a peer-reviewed journal as a piece of work, or as a conference paper where you can step up and then also expose yourself to the Q&A in a conference setting and so on. This is very, very important. I think that's a great opportunity for somebody who has a commitment, who has a talent, who has a nettle and an ambition. And so good luck, to you guys and to the whole program. So I have a lot of respect for Kostas. He's been done very, very significant work, pioneering work in the field on computational design, and certainly he can guide you. Absolutely.
Maybe I could just add something there. One of the challenges, I think, for architects is the fact that we've already had to do quite an exceptional long training process, especially if we want to graduate and be licensed. And I know, Krid, I couldn't notice on your presentation the word architecture appeared. Of course, you are an architect, but you're already in a different area in terms of computer science. Architecture is a kind of different sort of world. But let me just throw something out there, and that's to say that I don't know if you were aware of this, but Stephen Wolfram, who is one of the big figures in the world of computer science, he got his PhD at the age of 20. Can you imagine that a PhD at age of 20? Oh, in architecture, I mean, he was a child prodigy, right? He started early, but I mean, in architecture, there are very few people who even finish I mean, I think 6 years certainly in the UK, and I don't know where elsewhere. But you know, by the time you've done that, then you start a PhD. That's one of the big challenges. I think possibly why there aren't so many PhDs in architecture. I mean, when I was a student in Cambridge, there'd be people graduating with a PhD in the sciences at the age of 23, whatever it was. It was kind of standard. We have to go through this long kind of process. Any comments, any thoughts about that? Or if not, I've got some particular questions for. Okay, so maybe Dia, the one thing I wanted to just pick up on. I mean, I think your work is. I mean, first of all, there's computationally, it's kind of brilliant in many ways, but there is a question maybe that Patrik sort of raised, and I just was not quite clear about that, and maybe you could comment on it. It's the idea that that somehow that the machine could have a sense of self, you know, or I'm not quite sure what that means, because one of the big issues in terms of debates about consciousness and so on is the machines don't think, they're not self-aware, they're not sentient, they're not aware of what they're doing. They can beat us at Go and chess and things, but they don't know they're playing that. So maybe, are you saying that there could be some kind of self-awareness that's coming out of the system? What exactly do you mean by self in terms of your research?
Thanks, Neil, for your question. Well, the starting point of my research is that is following the school of thought of object-oriented ontology, that it's not human-centered. The world is not human-centered and anthropocentric. And about the self-replicating part, well, I think it's most of the well, a big portion of the AI theorists is interested in the problem of the self, of AI and consciousness. But in our thesis, it's based on the philosophical ground of behaviorism, and we judge it is self-conscious or self-aware based on their behavior. And I choose a field of art, AI art. The reason is that based on the conclusion of a paper from Kostas and Filippo and Professor Li, the outcome of the AI art, the important thing is that the result, and we observe the result of the AI art program, and in itself, it's intentional, the piece of artwork itself.
You know what I feel, just a few comments. When we're talking about AI art, when it comes to, let's say, a pragmatic art, functional art in terms of photo generating plausible, you know, quasi-humans through photorealistic but fresh generated pictures and so on, that's you know, that's quite different from the art world and the way the art world, the concept of art there. The one is more technically oriented towards use in entertainment, advertising, has purposes and functionality, and the art world, I don't know where this where art is valued in kind of very kind of subjective and fluctuating way, and NFTs are part of it. There's a big distinction here, and we shouldn't confuse that. And I think that the concept of intelligence, artificial intelligence, attaches more to the first, meaning where you have some kind of performance feedback criteria, where you can have intersubjective testing whether an AI generated face, for instance, is a good, highly plausible and expresses some of the features you've been tagged in semantically, and in particular also. So I do feel it's important that that when it comes to artificial intelligence, that one stays in the kind of world of with performance criteria and innovations, which and I think the art world is a kind of highly is very problematic in this respect, where you don't get that, where it's all about random novelty transformations and not cumulative any form of optimization. But I thought another thing which might be helpful to you, I'm not sure if you still, here you are. So basically when you're talking about, I wouldn't go into the concept of self-awareness, and you didn't use that phrase, you said self-understanding. And you need to kind of find a way to operationalize that, which is somehow, where I would say what the system, and then we don't have to talk about consciousness, where a system somehow uses some meta language or uses some kind of insight upon its own processes. Another algorithm looking at its process and process optimization to another set of criteria, some kind of reflection process. That might be a route, because I think when you talk about, you get some of this discussion in the autopoiesis discourse. I mean, when and in figures like Luhmann, and in terms of social entities knowing themselves, where consciousness isn't involved. You know, how can a corporation understand itself as a certain mechanism of self-observation, self-measurement, self-comparing states and statistics and so on? There is no consciousness involved, but there's a kind of self-reflective and self-steering involved. Maybe that's a better, to ward off right away that the whole kind of hornet's nest of consciousness and self-awareness, and see where you go with this kind of self-understanding, self-reflection, and so on. It might be way forward, rather. And I would just say that.
Yeah, no, I
Also, just one more thing on that, and the self-understanding is always partial. It's always a complexity reduction, right? It's always another mask, another set of filters through which the self-understanding or self-reflection is happening. There's always loss of information and particular, but always also a performance aim which structures that self-observation. I mean, Luhmann talks about second-order observation, self-observation in systems without consciousness. If you're interested in that, and I think there would be and could be definitely equivalence in computational science and AI. Herbert Simon was somebody who started coming also out of organization research into AI. Anyways, it's just an intuition I have, although I haven't deeply studied this with respect to recent conception of AI. But that's where I would go. Not talk about self-awareness, but some kind of reflective self-representation of internal states through a meta language. And there's fantastic interest. I mean, where it's more tangible when you have robotics and collective robotics learning. And there's an fantastic. I might get the book out and put this into the chat here. There's some kind of interesting experiments where groups of robots living in the world and having AI processes develop actually language and categories, in this case spatial language terms. So there's a kind of collective self-generation of linguistic capacities, which also rely on some degree of self-observation.
Maybe I could just add something that, I think that to kind of pick up on Dean's things, yes, I two things. One of the you said that the important thing is what was produced. That was the final issue. What can it produce, and that's really the key question. And I absolutely and totally agree with that. We don't, with machines, we don't care if they're conscious as long as they produce something. If my toaster produces good toast, that's fine. And I think I take the same view in terms of AI. If it can generate interesting work, then it's important. And in fact, in the question about self-awareness and things, provided that human is part of the loop, provided the human is part of the loop, which inevitably is the case, then we don't need the machine to be self-aware. I mean, we are self-aware. I mean, in fact, Yuval Harari says that actually it could be a problem if you're self-aware. He talks about a Google car that was crashed into by a human driver because the human was distracted. Better to have a self-driving car that's completely reliable than a human driving it from that point of view. So I don't think that necessarily we need a human to do, but I think what's important right now is the way in which we can see it, as you put it, in terms of an extension, as it were, of human intelligence. In fact, I use the term extended imagination, which is maybe not right, because I'm not sure we can use the term intelligence or imagination to refer to computers, but certainly humans have them. And it strikes me, the model I'm thinking, particularly in the case of the diffusion platforms that have been so effective, is that they show up how limited our own imagination is, because it's quite clear that somebody with DALL-E and Midjourney could do better than someone without it. I mean, that's the key question. We're very good at discriminating, at judging what we produce, but I think we're not as creative as we think we are, and I think our limitations are there. And this is where you can enhance things by generating outcomes. I mean, just astonishing outcomes. I mean, tomorrow we're talking about the city, and I've just been generating over the last few days some amazing stuff that Midjourney is producing about the city of the future, and it's just stunning. So I think as an augmentation to human intelligence, I think that's the primary role that it has, and I'm not so sure whether we need to be self-aware. But I must say, I think I look forward to seeing your research, because I think you've got some incredible ability, and I'm sure that it'll produce something really significant. We're going to have to wrap up very soon, because it's very late for you in China. It must be about 1 o'clock in the 1:30 in the morning, or midnight. Just to wrap it up. So I'm just. I mean, I have a number of questions which I would love to ask, but I haven't got time to ask. Krid, you introduced a term which I wasn't aware of before. Copyleft. I've been Googling that and trying to find out what copyright and copyleft is. That was certainly an interesting kind of contribution. And I think I'm excited by with Patrik, and I'm a huge admirer of Kostas. I mean, I think he's an incredibly energetic individual, and I think this new center is going to produce something. Who knows what it's going to produce? It's something astonishing, I think, for sure. So I mean, maybe I can just maybe invite Patrik for a final sort of thought, kind of comment on what we've seen today and the kind of aspirations for the future. Patrik, would you like to say a few words?
Well, yeah, I mean, thanks for a lot of making this happen, Anil. It's really been nice to see the group and also see it across 2 institutions. Yeah, congratulations to all the presenters. Thanks, Snow, you did a very good condensed summary. I just thought that the path deviation measure wasn't explained. I was urging to say, the way this measures this kind of deviation or detour imposed by some kind of human intuitive heuristics or a simulation thereof, relative to the actual shortest path. So there was something missing, just to throw that in there, but a very, very good condensation. And I thought the other candidates also done a good job. I mean, I was very skeptical about, I think the limit was 10 minutes. and maybe it's because I know the PhD so well that I really thought it benefited me quite nicely to see it so condensed. So yeah, I was very happy to see progress, and it's great. I think you did all great job to to hierarchize and punchline, ambitions first, and then showing how you're working on it, and some very interesting work. So yeah, it was very satisfying. And let's say, although I started off by being provoked by Andrea saying that everybody teaching in architecture must now have a PhD. I was kind of hey, I said hey, but ultimately this is very encouraging, and I hope it will bring more, inspire more people to take that dive and risk. But there will be help at Tongji for sure. So I really enjoyed the session. Thanks, Anil.
So let me just finish off with just so we can just to repeat something I've already said, I'll just scribble this down very quickly. But so have I got that right, Virginia? Info digitalfutures.world. That's the kind of the general Digital Futures question into information email. And if you have any questions, we can send it there and they can be forwarded to the respective people. There's a December deadline for Chinese students. It's coming up very quick, very soon, and a March 2023 deadline. Ooh, my spelling mistake, typo there, for international students. And both Patrik and I certainly would welcome applications for this. Patrik has got a very high standard. I know that because I know that Daniel Bolajan is one of Patrik's students. But anyway, this is hopefully we can build upon this. You know, this first cohort, which I think is super exciting to see both the international PhD students beginning to come to the end of their research and some really astonishing work coming out of that, and the excitement too, which I think in many ways is almost as the moment when things are launched, which is I think the most exciting moment. There are problems, there are glitches, there are all these things, but nonetheless there's an excitement of the moment itself, and I really look forward to seeing what comes out of Kostas's project there, this AI in the Department of Design and Innovation. One of the top schools in the world for art and design, and equally in the School of Architecture, one of the top schools in architecture. So we have something very promising here. I'd just like to thank our presenters for their presentations, all really fascinating today. I'd also like to thank the team behind all this, and of course Patrik for joining us today. It's always great to have Patrik's enthusiasm and his energy to tap into and to inspire us and to take us further. We are going to have another session next month with it's going to be the FIU DES program, which is a very different model to this model, or indeed the MIT Media Lab model. There are many different ways of doing a PhD, just as there are many ways of designing a building. And so we'll look at that. We're going to look in the new year. We're going to look towards towards other institutes, RMIT in Australia, which of course is a different time schedule because they're in the Southern Hemisphere. And we're also going to extend out this series to include master's programs. So at the moment, we've just been looking at inside PhD programs. We'll have inside master's programs. This will be uploaded to our YouTube channel. And I would simply say that, for those interested in PhDs, please have a look at this one. Also have a look at MIT Media Lab, ETH Zurich, ICT Stuttgart, UCL Bartlett, and also have a look at the doctoral consortium, which I think has been generating a lot of material that is there to be shared. There's some wonderful sessions, series. We have the AI, Neuroscience and Architecture. You can find that if you go to digitalfutures.international and look under the doctoral consortium, you can find it there. And there's ongoing things happening as well. And tomorrow we finish off the next to the doctoral consortium series on AI in the city, on the 2 books that have come out recently. So this is, I'm energized by all this, excited to see this. I'm even more excited to see what you guys eventually end up with. And it's great to meet you, Duan and Krid. I think I'm sure your work's going to be remarkable. Certainly your CVs look extremely impressive. So I'm sure there'll be some wonderful work coming out from this. So thank you everyone for this session. It's been a very special session. We will return next week to our normal starting time. We started a little bit early today because of many of our presenters in China, but we're back at the usual starting time 1 hour later next week. So thank you everyone. Thank you, Patrik. Thank you, presenters. Thank you, Digital Futures team. And thank you also, Philip, in the background. Thank you. Thank you.
Thank you, Neil. Thank you.
Thank you.
Neil,
I
I just want to do an observation regarding what Patrik said. No, it was a constatation because here it's needed, point. It's not that I agree with that. And I really hope that because of that, I'm not sure if the students, the professors will be better because of that or no. I have a lot of doubts regarding that, but I really hope that they can engage and they can think and have a time to do a deep study as we are all doing. Perfect. So thank you for that.
Absolutely, absolutely. And we're hoping to get Antonio Damasio in himself be part of the doctoral consortium as well, which will be a wonderful moment when we can mention that happen. He did agree, but we couldn't find a time slot to make it happen. Thank you, everyone. See you tomorrow for the doctoral consortium, those who want to watch it. This has been a really encouraging session. It's put Tongji on the map, I think, especially for the international students and things, and we encourage those to apply. We want to build upon the success for the future. So thank you, and see you tomorrow.
Bye bye. See you.
Thanks,
Good
everyone.
luck.
Good night.
The new
Bye-bye.
PhD students.